students, now I am going to discuss about the pressure. Okay, we have already discussed hydrostatic law, that is dP by dz is equal to gamma and P is equal to gamma into H. Okay, in fluid mechanics, as I told you, pressure can be expressed in number 1 in Newton per meter square or Pascal, number 2 in meters of a particular fluid, that is from here. Okay, so that is H is equal to P by gamma. Now, why we are converting this pressure into meter of a particular fluid? Because it makes our power calculation easy also. Now, let us see to find out what will be the pressure. Suppose we know mercury specific gravity is 13.6. Okay, 13.6. So weight density of mercury becomes 13.6 into 9810 Newton per meter cube. This is the weight density of the fluid. Okay, now this height will be there. So this unit have the Newton per meter cube. Okay, and if you multiply whatever meter is there, if we multiply, so P is equal to, see, this is 13.6 into 9810. If we multiply by meter, that is head. That head may be 100, 10, 15, 200. That will give us, suppose I am taking this 100. So this will be 1360 into 9810. This will be the pressure of this intensity. Okay, so this pressure is, see, converted. If the specific gravity is there, that means this gravity can be converted into weight density. So weight density becomes 13.6 into 9810, and if you multiply by head, how much height is there, pressure is the function of depth. As deeper we go, we feel more pressure intensity. Okay, so multiply by that H, it will give us a pressure. Another concept is there in fluid mechanics, that absolute pressure and gauge pressure. Okay, now see, this is called absolute pressure line. Okay, and this is called atmospheric line, atmospheric pressure, and this one is called total pressure, P absolute. Okay, another concept is also there. This is P atmospheric. Okay, this is P atmospheric, and this is called P absolute, and this is called P gauge. And this is gauge pressure, that is PG. Okay, now equation becomes P absolute, see here, P absolute becomes P atmospheric plus P gauge. Okay, P atmospheric plus P gauge. But another case is also there. See, P atmospheric becomes P absolute plus P G also. Okay, so this equation 1 and P absolute will be equal to P atmospheric minus Pg. That is equation 2. Remember, equation 1 we are using in thermodynamics. That is absolute pressures. That we are using absolute pressures. In fluid mechanics, we are using gauge pressure. Gauge pressure means pressure less than atmospheric. See, this gauge pressure will become atmospheric minus absolute pressure. So it is negative pressure. Okay, so absolute pressure in the case of fluid mechanics will be atmospheric pressure minus gauge pressure. So this pressure will have lesser value. Okay, that is lesser than atmospheric value. Okay, so that is why these are called gauge pressures also. Okay, so this concept in fluid mechanics we are going to use this concept. From here only P atmospheric will be equal to P absolute plus gauge. Okay, P absolute will be equal to P atmospheric minus gauge. Okay, or we can call it as P atmospheric will be equal to P absolute minus plus Pg. Okay, but in thermodynamics pressures are very high range, so there all the pressure we are considering above atmospheric pressure is 101.325. Okay, so 101.325. This is Newton per meter square. This is kilo Newton per meter square. Okay, so this is atmospheric pressure, and if the pressure ranges are more than this, they are called absolute pressure. That we are going to use in thermodynamics. Pressure which is less than this value will have negative. That is also called vacuum pressure. That we are going to use in fluid mechanics. Okay, so let us sum up what we have studied in this session. We have already discussed hydrostatic equation, that is dP by dz is equal to gamma. So P becomes gamma into H. Pressure can be expressed in two forms. That will be in the Newton per meter square or Pascal or kilopascal or Newton per mm square also. Okay, in meters of a particular fluid also. That means H will be equal to P by gamma. Okay, so suppose Hg, we have to find out the pressure of Hg. So specific gravity of Hg is 13.6. If we multiply by 9810, because specific gravity is nothing but weight density of a fluid divided by standard fluid. Okay, so standard fluid is water, so 9810, that becomes the weight density of the mercury. And if we multiply this value to the head or height of this fluid, how much meter is there mercury? If we multiply by that head, it will give us a pressure. That becomes Newton per meter square. Okay, now absolute pressure and gauge pressure. See, this figure you have to remember. Absolute pressure is sum of atmospheric pressure. This is atmospheric pressure and gauge pressure. Absolute pressure line, this is absolute pressure line. Absolute pressure line means this is datum line. Okay, from here we are calculating datum line. So this is atmospheric and this is gauge. So absolute pressure will be sum of atmospheric pressure and gauge pressure. This equation we are going to apply in the thermodynamics. And another equation is also there. From here, see, P atmospheric becomes here P absolute minus gauge pressure. Okay, so P absolute is P atmospheric minus P gauge. Stated unless specified, all the pressure given in fluid mechanics will be less than atmospheric pressure. So they are called vacuum pressures also, and we are going to use that pressure only in the fluid mechanics. Okay, thank you. Rest